Now, it's no secret, and I'm sure you've heard it all before, but biodiversity is currently under threat. I found a quote from a paper that's really great. I put it at the bottom there so you can read it if you like. That kind of sums up the kind of scientific consensus around biodiversity, and it says the most unique feature of Earth is the existence of life, and the most extraordinary feature of life is its diversity. Approximately 9 million types of plants, animals, protists, and fungi inhabit the Earth. So too do 7 billion people. 2 decades ago, at the first Earth Summit, the vast majority of the world's nations declared that human activities were dismantling the Earth's ecosystems, eliminating genes, species, and biological traits at an alarming rate. This observation led to the question of how such a loss of biological diversity will alter the functioning of ecosystems and their ability to provide society with the goods and services needed to prosper. So, how do we know biodiversity is decreasing? In the last 10 years, 121 species have become extinct. The IUCN lists 16,928 as threatened to be extinct. However, extinction is a normal part of evolution. Over 99% of all organisms that have ever lived are now extinct. So why is it such a big deal now? Many historical extinctions took place in the background. Now, a normal background rate is considered to be one extinction per million species per year, although a very recent scientific paper has indicated that the background extinction rate is much lower than this, at 0.1 extinctions per million species per year. The current extinction rate is 100 to 1,000, and if the new study is correct, 10,000 times greater than the background extinction rate. So what does this mean? There is a growing consensus that the extinction rate means we are headed for the sixth mass extinction, and this has been dubbed the Holocene extinction. A mass extinction is an event when Earth loses more than 75% of species in a geologically short period of time, and this has happened only 5 times since Earth's formation. The last 5 have been caused by massive climate change, catastrophic methane release, impact events, and flood basalt eruptions. So if climate change has caused a mass extinction before, how do we know that this one is due to us? So, although climate change has happened before in Earth's history and has caused mass extinctions, scientists that report to the Intergovernmental Panel on Climate Change have come to the conclusion that we are the cause of this mass extinction. Now, if you want to see in detail how, and it's an interesting read, you can Google the IPCC report, although I do warn you, it is very technical and it is very wordy. Climate change is one of the biggest threats to global biodiversity. The IPCC report includes the following observations made by scientists from around the world, and the ones at the bottom here are from NASA, which I thought were quite cool. So, oceanic and atmospheric temperatures are rising. Amounts of ice and snow coverage on the planet are decreasing. The sea level has risen, precipitation over the northern hemisphere has increased, Oceanic salinity is changing, oceanic acidity has increased by 26%, and there has been an expansion of the tropical belt. And that's just a quick snapshot I've taken from a brief read. If you read that thing through, the list will be as long as your arm. The changes are alarming, and there are many of them. So what is driving climate change? There are many complex and interacting factors that can, and in some cases are thought to play a role in the current state of climate change. So for example, we've got biotic processes, variation in solar radiation, plate tectonics, volcanic eruptions, Milankovitch cycles. However, overwhelming amounts of scientific research has shown that the biggest driver of climate change is human activity. So the IPCC reports that there is a 95% chance, or they report with a 95% confidence, that human activities over the last 2.5 centuries has caused the climate change we are seeing now. But what have we done to cause this? And the answer is pretty much massive output of greenhouse gases. In a nutshell, the Earth's climate is primarily the result of the rate at which Earth receives energy from the Sun, and the rate at which this energy is then lost to space. If more heat is lost than gained, Earth cools. If more heat is gained than lost, Earth heats up. Greenhouse gases essentially trap the heat and stop it radiating back out into space, which causes a global rise in temperatures. Now, carbon dioxide, I'm sure you heard of this one before, is essentially one of the big baddies of the greenhouse gases. It has increased 43% since Industrial Revolution. Pre-industrial CO2 values were 280 parts per million. CO2 values in 2005 were 379 parts per million. CO2 values in November 2015, which I got from NASA, were 402.23 parts per million. Sorry, there is meant to be a million on the end there. Prior to industrialisation, CO2 rose only by 20 parts per million in 8,000 years, primarily caused by a combustion of greenhouse gases and deforestation. And now one thing I hear often when I research the kinds of things online and I go on forums is, aren't volcanoes the biggest drivers? They emit loads of CO2. Yeah, they do. They emit about 0.3 billion tonnes of CO2 a year. However, humans produce about 29 billion tonnes of CO2 per year. So you can see the difference there. We produce so much more. Now, methane is the other big bad greenhouse gas, but you don't hear too much about it. Atmospheric levels of this have increased by about 150% since 1750, and they are currently at the highest levels in the last 420,000 years. Just over 50% of methane emissions are man-made. The sources of anthropogenic methane emissions are thought to be cattle ranching, burning fossil fuels, and accidental release during natural gas drilling. However, methane levels aren't as high as carbon dioxide levels, and trust me, you wouldn't want it to be. Methane is about 25% more potent as a heat-trapping gas than carbon dioxide. If it rose to the levels of CO2, we're going to have a problem. Now, nitrous oxide is one you might not have heard of so much, and it's way more potent than carbon dioxide. It's 298 times more potent. So, since the Industrial Revolution, it's thought to have increased by 16%. There is so much debate surrounding the actual source of anthropogenic emission of nitrous oxide. However, an undisputed source is fossil fuel combustion. It's one that is currently, I'd imagine, under research, and there's not too much known about the actual anthropogenic emission, other than burning of fossil fuel. I haven't been able to kind of pin down anything else. Water vapour is one that was very recently discovered to be a player in the climate change game. It's a lot more complicated and is a current area of climate research. So in 2008, NASA identified it as a major player in the climate change game. It is Earth's most abundant greenhouse gas. Heat radiated from Earth's surface is absorbed by water vapour molecules. However, unlike the other greenhouse gases, it is controlled by Earth's temperature, the rising of which is caused by greenhouse gases. So this is an example of positive feedback. A rise in greenhouse gas causes a rise in water vapour, which causes a rise in temperature. I've put this at the bottom just to kind of summarise it up a bit. I found it quite hard to read about. It gets very complicated very fast because it is such a brand new area of research. So if you want to read more about that, feel free, there's plenty of it about. So I've made a separate presentation about climate change and the effects on life, and I've done it by using the findings of several scientific surveys and investigations that have taken place over many years. It will give you a very general look at how climate change is affecting life on Earth, so do feel free to take a look at that, and I'll see you on the next bit.